Welcome to Maths for All. I'm Aisling Flynn. This is Functions 1.8, Solving Problems. So what we have here is a typical functions question. The graph shows the functions below in the domain -5 to +5. Okay, so in the blue we have f of x, which is a quadratic function, and in the green we have g of x, which is a linear function. So the type of questions that would be asked on this graph are, so question A, we have for what values of x is f of x less than or equal to 0? So firstly, to put it into English, it's asking when are the outputs f of x of the function less than 0. So when are the outputs less than 0, or when does the function on the graph, when does it go below the x-axis? So let's recall that the f of x values usually appear on the vertical or the y-axis, and when are they less than or equal to 0? So 0 is here on the y-axis. When are the values lower than that? So it's asking when are they negative, really. And this blue line, which is f of x, is below the x-axis for all of this section. Okay, so essentially from here to here. Okay, sorry, my pen doesn't like circles. Okay, so the function goes below the x-axis between the values of -2 and +3. So we're looking for the x values. And we can write that, we can say the function is less than or equal to 0 when x is between -2 and 3. And we can write it like that. So x is to the left of -2 and to the right of +3. And if an equal line is used with the inequality as it is up here in the question, well then you can include it in your answer. Okay, so it's including those values. So part B of this question asks for what values of x is x squared minus x minus 6 greater than 0? So it looks a little bit different, but what you've got to recognize is that x squared minus x minus 6 is the function f of x. Okay, there's x squared minus x minus 6. So this time it's asking when is the function greater than 0? So when are the outputs of the function greater than 0? When does the function go above the x-axis? So we're looking for parts of the blue function that are above the x-axis. So we find those, well, there's a part here on the left. Now remember that this function could technically go on forever and ever. All right. So here we see it is above the x-axis as far as -2. And when you get over as far as +3, then it is above the x-axis again. So all along here. And again, yes, it can continue to infinity. So the function goes above the x-axis to the left of -2 on the x-axis and to the right of +3. Now you can see clearly on the diagram here that what I've marked in red, there are two distinct areas on the graph and they're not joined up. So we will write them as two separate answers. So when x is smaller than -2 is the first one. So x less than -2, and when x is greater than 3 is the second one. Okay, notice we don't include an equal bit to the inequality here because it wasn't in the question. Okay. If the regions are separate on your graph, you must write them separately in your answer. It's not possible to join them up. Okay. Part C of the question. Use your graph to estimate the value of x when f of x equals to 3. So what is 3? 3 is an output. When you put your number in and you do the function, 3 is the answer. It's an output and it's found on the y-axis or the vertical axis. So we have to locate 3 there, and there it is. Okay, we need to use the graph. So when, and I've underlined this, when the question says use your graph, that's exactly what you must do. The examiner does not want to see you using algebra and substitution and all of this. They want to see you interpreting the graph. Use the graph to estimate. Estimate is a word used that allows you to have a slightly different answer to the student next to you. And the reason for that is to allow for slight differences in your graphs, because mostly your graphs are hand drawn. Okay, so we have to use the graph to estimate the input values on the x-axis. So what gave answer 3? So how do we do this? Well, here's y is 3. Okay, so what I'm going to do is I'm going to draw a horizontal line, okay, where y is 3 until it hits my function, and then I'm going to drop down until I hit the x-axis and find the input that gave output 3. Okay, and the values of x that give an output of 3 are minus 2.5, you can see that here, it's halfway between 2 and 3, and plus 3.5, that's the one here. Okay, answers may vary slightly from student to student due to graphs that are hand-drawn. Some differences tolerated in the marking scheme, so that's okay, but illustrate your answers on the graph to show where you got them. So I would always do that, okay? Even if you wrote down the wrong answer by accident, or you wrote plus 2.5 instead of minus 2.5, if you've shown what I've shown there in red pen on the graph, you should get your marks. So question D, use your graph to find f of 2. So firstly, we must recognize that 2 is an input, it is an x value, and it can be found on the x-axis. So when you see it in the little bracket there beside the letter f, it equates to an x value. Okay, it's an input. So find that on the x-axis, there it is, x is 2. And then we will use the graph and we'll estimate the output, which we'll find on the y-axis where the f of x values are. Okay, so starting at 2 on the x-axis, we'll go up or down to hit the function, which is the blue one, f of x. So in this case we have to go down if we want to hit it, so straight down when you hit it, and then you go left or right, in this case left, until we hit the y-axis, which gives me an answer of minus 4. So the value of f of x when x is 2 is f of x equals minus 4. Answers may vary slightly again from student to student, okay, and that's tolerated, but again, show your work on the graph. Part E asks, for what values of x is f of x equal to g of x? Now, what does that mean? So f of x was the blue curved function, quadratic, and g of x was the green linear function. So what it's asking you is, when are both graphs the same? When are they equal? When are both graphs in the same place? Okay, and in this case there's going to be 2 places. They're in the same place where they cross over. So here and here. Okay, and a clue is there when it says for what values, so more than one. Okay, and we're looking for the x values of those points. So what are the x values at these places? Well, I can see that one is minus 2, that's here, that's easily read, and the other one, if we draw a line straight down from the point, we see that it lands halfway between 3 and 4, so it's 3.5. Now, question F says, for what values of x is x squared minus x minus 6 equal to x over 2 plus 1. Now at first glance this looks not so nice, but hopefully after a bit of practice you'll quickly recognize that x squared minus x minus 6 is actually f of x, okay, equal to, and x over 2 plus 1 is actually g of x. So in actual fact this question is exactly the same as the previous one. This is the same as asking when is f of x equal to g of x. We found those two places and we should give the same answers. This is the same question as part E, and they are equal when x is minus 2 and x is 3.5. Now part G builds on that. It says verify your answers from part E and F using algebra. So here we do have to go to algebra. So when is f of x equal to g of x? When is x squared minus x minus 6 equal to x over 2 plus 1? So what do we have to do here? We have to solve this equation. Okay, so go back to your algebra skills and the equation, golden rule. If you make a change to the left, you must make the same change to the right. And if you stick by that, you can't go too wrong. Okay, so at first glance here, the first thing I see is this 2 under the line. I don't like that, it's a fraction. So to eliminate that, or to make it go away, I'm going to multiply the left hand side by 2 and also the right hand side by 2. Right, I'm going to write that down first. Left hand side by 2, x squared minus x minus 6 is equal to 2 times x over 2 plus 2. Plus 1, sorry, getting ahead of myself. Okay, so on the left hand side let's multiply and remove that bracket, so we get 2x squared minus 2x minus 12 equal to, now 2 times x divided by 2, what does that give you? Well, it just gives x, so 2 divided by 2 is 1, okay, or a half x multiplied by 2 is 1x, and then 2 times the 1 is 2. Sorry, that should be a plus, x plus 2. Okay, now clearly because of the x squared part we're going to have a quadratic equation, and we usually solve those by having everything on the left equal to 0. So what we're going to do first is remove anything on the right, so we'll take away that x. If you make a change on the left you must make a change on the right that's the same, and we're going to take away that 2 also, take away that 2. Okay, so what are we left with? 2x squared minus 3x minus 14 equals to 0. Okay, and this is what we're going to have to solve. Now you have choices here. You can solve by factorizing, okay, which I'm going to do because by far the quickest if you can figure out the numbers, factorizing, or if you find that difficult you can go to your minus b or your quadratic formula. Okay, so factorizing. Now you can write this whichever way you wish. I'm going back to this grid method because we looked at that a long time ago. Alright, doesn't matter how you work it out as long as you get the right answer. Okay, so how do we make 2x squared? Well, we get it by multiplying 2x by x. Okay, and how do we make 14 by multiplying? So this is the slightly harder bit. We can do 14 times 1 or 7 times 2. Okay, and we need to make a choice so that we get minus 3 in the center. Okay, and so I'm going to choose 7 and 2, and you'll see why in a minute. Okay, so if we fill in the empty boxes we'll see does this work. Okay, so 2x by 2 gives 4x, and x by 7 gives 7x. And if we want a minus 3 in the center, which we do, we'll have minus 7x plus 4x gives me minus 3. 7x. Okay, now so if I want a minus 7x there, I have to put a minus there, and we'll have a plus here. So go back and revise your factorizing if needs be. Sorry, that's a mistake now. My factors are along the sides. I have a one is x plus 2 and the other one is 2x minus 7. Okay, put it equal to 0 because there was nothing on the right hand side. Now the next step is to put each factor separately equal to 0 and solve. So take 2 from both sides, and this one gives me a result of x equals minus 2. The second one, put it equal to 0, 2x minus 7 equals 0, add 7 to both sides, 2x equals 7, divide both sides by 2, we get x equals to 7 over 2, or x equals to 3.5. Now, weren't they the same two answers as we had previously? Okay, and it's nice to know that we are right. So again, revise your algebra if need be. Now, the next part of this video is a question from the 2019 Ordinary Level Leaving Cert Paper 1, and it is a functions question, but it tries to put it in a real life context to describe something in real life. Okay, so the first part, a camogie goalkeeper. So camogie, if you don't know, is the female version of hurling, Irish national sport. Okay, a camogie goalkeeper on a level pitch hits a ball straight up into the air. Okay, the path that the ball travelled can be modelled by the function. So functions are used to model things, to describe things. So this time it's f of t equals minus 4t squared plus 16t plus 1, and t is an element of the real numbers. So t refers to the time, okay, in seconds when the ball when the ball is hit, and f of t gives the height of the ball in meters above the pitch. The ball landed on the ground without being hit again. At what height was the ball when it was hit by the goalkeeper? Okay, so is the first question. When it was hit by the goalkeeper. So when refers to time, and time t in the description here is the time from when the ball is hit. So when the goalkeeper hits it, that is time 0. Okay, so what we should find here is f of 0. Should give us the height at time 0. So firstly, I would get into the practice of always writing down my substitutions. Okay, yes, you can do it on the calculator, but show the examiner what you're doing. In case you make a mistake, hit the wrong button. Okay, so the first line there, I substituted 0 instead of t. We get 0 plus 0 plus 1, so the answer is 1. So when she hits it at a height of 1 meter. Okay. Complete the table below to show the height of the ball at various intervals during the first 4 seconds of its flight. So already we've seen that at time 0 the height was 1 meter. Okay, now what we need to finish this off is we need the actual function. So just looking back, the function was minus 4t squared plus 16t plus 1. Now here you have a choice. You can go through each of the values of t, okay, and calculate each one, okay, on your calculator, or you can pause here and use the tables function on your calculator to get all the answers for you. Okay, so I invite you now to pause and do that. And here's a tip for the calculator: use step equals 0.5. Okay, so I've done that, and the answers I get is at time 0.5 I got 8, then I got 13, then I got 16, after that I got 17, after that I got 16. So this one is put in for you, so that's nice. You can check, are you doing it correct? Do you get a value of 16 there. 13, 8 and 1. Okay, and you've all the space if you needed to work out, but you don't need to use that space if you don't need it. Okay, so there's our results, and I think we'll need those for the next stage. Okay, the next part asks us, on the grid below, draw a graph to show the height of the ball while it was in the air. And yes, we do need to use our results from the previous part. Okay, so let's plot here. When time was 0, so just take a quick look, time is along the bottom and height is along the side. Okay, when time was 0, so that's right here at the edge, the height was 1 meter, so that's here. When time was 0.5, so 0.5 will occur halfway between 0 and 1, the height was 8, and so on. Time 1 we have 13, 1.5 is 16, 2 seconds is 17, and then you'll see they'll go back down. It's quadratic, it's going to be symmetrical. 16, 13, 8 and 1. Okay, and we'll join it up as smoothly as we can. Okay, as long as you have the key points plotted correctly, then you'll get your marks. All right, so this is as expected. It was a negative quadratic function which is hill shaped, and it should be symmetrical. Okay, you'll do a better job of that than I. So part C says use your graph to estimate the length of time the ball was in the air from the time it was hit until it landed on the ground. Okay, so we do need our graph, which is here. So the length of time means we're going to get our answer from the x-axis, or the horizontal, because that's where time is. When the ball was in the air from the time it was hit, which is here at the very start, to when it landed on the ground. Now if we follow the track at 4 seconds, it's still at 1 meters high, so it hasn't landed on the ground. So this is where the word estimate comes in. So it hasn't hit the ground at 4 seconds, but if we carry on the line in the trend, we think it's going to be, it hits the ground a little bit after 4 seconds. Now here in the center is 4.5, so I'm going to estimate that to be 4.1 seconds. Now you could say 4.12 or whatever. So, but there is a tolerance in that answer, and that's allowed because each graph could be slightly different. Okay. Second part, the length of the ball was 10 meters or more above ground. Okay, so we're looking for length of time. That's from the x-axis. So 10 meters or more above ground. So 10 meters is a height. We find it here. I'm drawing a horizontal line. So the ball is 10 meters or more above from this point here, okay, to this point here. Now we need to know the time it takes for it to go up and down between those 2 points. So I'm going to drop a vertical line down and down, and I'm going to estimate. So I'm guessing this point here, it's a little bit more than 0.5. I'm going to say from 0.6 seconds to, and then the other side is, maybe my line's a little bit crooked there, I'm going to say here in the middle is 3.5. I'm going to say 3.4. Okay, now that's not the length of time. To get how many seconds above, we should subtract that. Okay, and I'll get 2.8 seconds is my answer. Now you might get a slightly different answer, and that's totally okay. The important bit, however, is if you show that on the graph where you got those numbers from, you'll get marks.